we would do the limit as h goes to 0 of what?
F of a plus h.
F of a, yeah, minus what?
F of a
All over.
a.
Or what?
Or
The limit as x goes to
a
of,
f of x.
yep.
F of a over a.
Can you use either one? Absolutely. So in this case, f of x is already defined. So if we were going to attack this right here, we could theoretically, which one do you want to use? The one on the left or the right? Ah, I love it. It's good. I actually wanted even division. That's totally fine. We can just write out each of them and then see what they look like. So we have the limit as h goes 0 of c times a plus h to the n minus c times a to the n all over what? H? Or the limit as x goes to a of cx to the n minus ca to the n all over x minus a. So let's look at those two. Which one looks like it might be a little easier to deal with? Yeah, just visually speaking, it looks like the one on the right will be easier to deal with, mainly because what's our goal in each case? What's our goal in each of these cases right here? Factor and cancel. Factor and cancel, factor and cancel. So sometimes this is easier because you just have an h and you only have to factor out an h. But sometimes when you're dealing with a plus h to the n, you might not want to have to deal with thinking about that. So let's take a look at this one. So if we keep on going with this, what could we factor out of the top? The c. You can factor out of the whole thing, right? It's going to c times the limit as x goes to a of x to the n minus a to the n, sorry. A to the n all over x minus a.
Isn't that like x to the first minus a to the first? So
What is x to the first minus a to the first?
yeah,
This is x to the first minus a. That is correct, sure.
But then if that's like this,
It's subtraction, not multiplication, correct. Okay, so at this point, what's our goal? What are we trying to do, Hannah? Factor, cancel, factor, cancel, factor, and cancel. So specifically, we can't factor the denominator. It's already done. It's simple. We can't do anything with it. What are we trying to factor? The numerator. We're trying to factor the numerator. Does anybody have any ideas of how we could factor the numerator? Yes. You could try polynomial long division, right? Exactly. What makes the denominator 0? Oh, well, no. We'll use polynomial long division. That's totally fine. So it's x minus a going into what? X to the n minus all the way to the a to the n. You have to realize a is a constant, right? Does a contain x? No, a is a constant. It's decided before you would do this. So if we started doing this polynomial long division here, let's just see what happens and see if it explodes or contracts, or let's try to notice something. The thing is, how many terms does this have theoretically? It has 2 terms, but how many are in between? An infinite number. Well, it ends because it's an n, but many, like many, 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 many of them, right? So we either get something nice or some pattern, or we're not going to use this method. So let's try it. We have x to the n over x. So what is that? X to the n minus 1. Do you agree with that? Yep. So you have x to the n minus 1. You agree with that? So if we do this, we multiply, we get x to the n minus 1 times what? Minus a times x to the... Oh, that's a to the x to the n. Yes, that's to the n. Yep, to the n. X to the n minus 1. So if we have to subtract this, right? What are you going to be left with? A x to the n minus 1. Okay, so now we do the division. We do a x to the n minus 1 over x, and we end up with a x to the n minus what? 2, right? When you multiply this out, what do you get? You get a x to the n minus 1 minus a squared x to the n minus 2. You subtract this, the first cancel, and you're left with a squared x to the n minus 2. Do you agree with that? So our new leading is a x to the n minus 2 over x. So you're left with ax to the n minus 3. Yeah, it's definitely going to keep going, right? So we're going to keep going here. So xm. So we get a squared x to the n minus 2 minus a... Hold on a sec here, everybody. Hold on. We're missing something here. Minus 3 all over x. So what do we end up with? A cubed x to the minus 4, correct? We multiply that out, you get a cubed x to the n minus, and then you get minus a to the 4th times what? N minus 4, right? So this is going to keep going, correct? Do you agree that this is going to keep going? So what we're basically saying is this. We're saying that x to the n minus a to the n is equal to x minus a times this really long thing we're coming up with, which is what? X to the n minus 1 plus ax to the n minus 2 plus a squared x n minus 3, a cubed x to the 4. And the question is, how far does it go? How far does it go? What is the last term going to be? It's going to be what? Yeah, you're the last term. Let's just think about this. You look at the powers here, everybody. I want to show you the first pattern here. What's the power of x right here? A right there. What's the power of a? And it's n minus 2 right there, right? If you add 1 and n minus 2, you get n minus 1. 2 and n minus 3 is n minus 1. So the sum is always going to be what? The sum is always going to be n minus 1. So the a's are keep on going up and up and up and up, right? So theoretically, they're going to get to the point where it's going to be plus a to the what? Think about it this way, everybody. Think about it this way. No. The last term we originally have is a to the n. Here, if we factor out an x minus a, what's the last term going to be here? It's going to be a to the n minus 1. Do you agree with that? Because if a to the n, if the last term was a to the n, what's a to the n times a? A to the n plus 1. Does that exist in the thing we're trying to factor? No, so the last term is going to be a. So my question is, what's the invisible term that's in front here? X to the what? Look at the pattern, everybody. What was the sum of these two things? N minus 1, right?
Yeah.
What's the sum of it right here? N minus 1. The sum is always n minus 1. Do you see that pattern? It's always n minus 1. X to the n minus n. X to the n minus n, which is 0. I'm just trying to show you the pattern. You need to see the terminal term in order to understand what the pattern is. Let's go one back. What would be one back from this? It would be a to what power? A to the n minus
2.
A to the n minus 2 times what?
X up to x.
And no, I'm going to put these in a different order. Hold on one sec. You see how I have them? I flipped the order there? This right here should be, and believe this will calm down. Don't get too shell-shocked right now. So this is a to the n minus 1, and you're not, and this is, I'm just showing you the pattern. It's not something you have to remember. So what's the one before it going to be? It's going to be a to the n minus 2, x to the n minus 1, right?
Did something get cut off in like the a to the n plus, and then it does, or is that minus 1? Oh, okay.
It's n plus. Okay. So does everybody see that right there? Do you agree that that's like that?
Yeah.
Okay. So here's the thing. So we're trying to do this limit right here. Do this. Okay. So let's write that again. It's c times what? It's c times the limit as x goes to a of this thing, correct? All over what? X minus a. And what's the cool thing we are now able to do? We can now cancel, which is great. So now we have this. I'm going to write this out for you, and it's really important that you recognize what's going on here. C times the limit as x goes to a of, what is it, x to the n minus 1 plus a times what? X minus 2 plus a squared x to the n minus 3. And I'll skip here. It's going to go all the way down. And the last term is going to be a to the n minus 1. Do you agree with that? You got that? Okay, so what is x going to? A. So what do we plug in for x? A. So what do we end up with? Let's just look at, be very careful. Just, let's keep quiet for 1 second. I don't want you to skip ahead and get the wrong conclusion here. So we end up with a to the n-1 plus a times a to the, don't think, just do this. A squared a to the minus 3 all the way to what? A to the n minus 1. And there's a c out front. Do you agree with this right here? Okay, so we have that. So what does this simplify to? Nope. A to the n minus 1. What's that simplified to? N minus 1. And this simplifies to a to the n minus 1. So all of these, just so you understand what's going on here, we now have c times the limit as x goes to a of a to the n minus 1 plus a to the n minus 1 plus a to the n minus 1 plus, what's at the end? The big question now is how many of these a to the n minus 1s do we have?
As many terms as you have in
N of them. There are n of them, exactly. As many terms. There's n of them. So if you have n of them, what's another way to write this big sum? C times x, so this is of what? There's n, a to the n minus 1. Does n revolve around x or a? No. Exactly. And did we, excuse me, we already took out the limit, right? We already took that out. Do we even need the limit anymore? We made the substitution. So what's our final answer going to be? Cn a to the n minus 1. So what we just found out, everybody, if f of x is equal to cx to the n, then f prime of a is equal to what? Cn a to the n minus 1. The way you generally see it written is, instead of writing it like this, they usually say f prime of x is equal to cn x to the n minus 1. So can you tell me what just happened there? Where did n go? Where did n go? Where did n start? I'll ask it that way. Where did n start? In the power. Where did it go? Coefficient. What happened to the power? What happened to the power?
You got subtracted by 1.
It got smaller by 1. And c, did anything happen to c? No, it did not. It did not. So, for example, what does this mean? Let's say I gave you this. G of x is equal to 1/7 x to the 4th. Can someone tell me, just raise your hand, but don't say it out loud. Raise your hand and tell me what the derivative is. What is it, Allie? Yep. Done. Did we have to do a limit of any kind? No. This is your payoff. You now get to skip doing a lot of that nasty stuff that you spent hours doing before. Go to lunch.
Wait, leave that right.
Let's ramp it up a little bit, I guess. But h of x is equal to 17x to the 3/2. Can someone tell me what's that going to be? What's h prime of x going to be? What's it going to be? 17 times 32. Yep. X to the 1/2. Done.
Wait, why is it 1/2?
Because 3/2 minus 1 is 1/2.
Wait, 3/2 minus 1/2 or 1?
1
Okay.
minus
So you
1.
always subtract 1.
You just always subtract 1. Okay, what about this one? Ready? Let's make it even more fun. Let's say I gave you this. How about e x to the pi?
Oh, wow.
What's j prime going to be?
Pi times e.
Pi times e
Minus
x to the...
X to the pi minus 1.
Done. Done. That's it. That's it.
minus 1.
That's one. These numbers are multiplied together. I say this once, mainly because I think I shouldn't have to say it at all. Because, for example, let's say I gave you n of x was equal to, I don't know, 5x to the 4th. I have people write this sometimes. No, it's not 54. It's 5 times 4. It's 5 times 4.
What if it's like
2x cubed, yeah?
plus 3x squared
Yep.
plus x
Yep.
plus 2 or something?
Plus 1, sure. What does p prime equal?
So would it just be like 6
X squared plus
6 x
Yep. Plus
plus
1. Plus what?
Plus 2.
1
Isn't it plus 1?
plus
No, because
0.
What is 0?
Ah! Because what is this? What is this? What is this? That is x to what power? 1, right? So what is n prime going to be? It's going to be 1 times x to the 1 minus 1, which is 1 times x to the 0, which is 1 times 1, which is 1. So you've been doing it the entire time, you just didn't know it, which is fine. Hold on one sec. If you do this derivative here, like this, you don't just subtract 1 and make it x to the negative 1. That's not true, okay? You don't do that. Just you have to think to yourself, if it is just 7, if it's just a constant, the derivative of a constant is 0. Just by definition, constant means unchanging. What is the rate of change of something that is unchanging? 0. Done. You just definition, okay? The derivative of the first one right there. What would you bring it up? So what does that equal? 3 times x to the negative 2. Correct. So what does that mean f prime of x is equal to? Negative 6, negative 3. Exactly. You always subtract 1, and the negative doesn't change. What do you have to do this one first?
It's
X to the what?
X to the
7/3. So therefore, y prime is equal to 7/3 x to the
X to the minus 1. X to the 4/3.
Hey, just keep saying it.
Yeah. X to the 4/3. Exactly right. Does it matter for the fractions? No. Does it matter if they are negative? No. The power absolutely does not matter. They just have to be real. Okay. Who wants to do the second one here? Who can tell me? Raise your hand. Who wants to do the second one? What's g prime? No. What is it?
7 6
Yep.
x to the 4th.
Cool. Okay. Can someone tell me what this one is? Someone raise their hand. Just tell me what it is. What is it? Anybody? Daniel, what is it?
2x to the x minus 1.
2x to the x minus 1? Like that? Okay. What about n prime of x? What about n prime of x? The last one. This is the last one here. Come here, see. What is it?
18
Over.
49
Yep.
x
To the.
to the negative 1 side.
Correct. 3 of those are correct, and one of them is absolutely wrong because I haven't had to do it yet. Which one is absolutely wrong? This is totally a trap. You've got the Akbar. It's a trap. It is not correct. It is not correct. This does not fit the form that I gave you. This is totally a setup. This does not fit the form I gave you. The form I gave you was f of x equals c times x to the n, right? Where is x? X is in the base, not the what?
Not the power.
Not the power. Not the power. Not the power.
Like,
Not the power.
Isn't that called something like the n, where the n is?
The exponent. Limit as h goes to 0 of c to the a times c to the h minus c to the a. Because what do you do if you have the same base as you add the powers, right?
Yep.
Just all over h. Do you agree with that?
Yeah.
Okay, so we now know the derivative f prime at a. The derivative at a is equal to the limit as h goes to 0 of what? C to the a times c to the h all over what? H. Does this right here depend on h?
No.
No. It does not depend on h. So what can we do with this? Where can we bring it?
We bring it over.
We can bring it to the front. Do you agree with that?
Yeah.
Okay, so what do we now know? F prime at a is equal to c to the a times, remember c is just the constant we started with. It could have been 7, it could have been 8, it could have been 9, times what? The limit as what? H goes to 0 of c to the h minus 1 all over h. You can't plug in zeros to anything. You can't plug in zeros. 0 over 0 doesn't necessarily equal 1. You are correct. The bottom, the denominator, is going to 0, and what is the top going to? The top is also going to 0, but just at 0, going to 0 over going to 0, does that mean anything concrete? No, you need further analysis. But here's the key realization here. The key realization is, what is this right here? The key realization is, what is this? And it's hard to see, but let's say I asked you this. Let's say I asked you for f prime at 0. Remember that f, you need to really not talk right now, is equal to c to the x. Remember f of x is equal to c to the x? Are we okay with that? Let's say I asked you for f prime at 0 using the limit definition. This is really important. We're doing f prime at 0 using the limit definition. This is going to be the limit as h goes to 0 again of f of, instead of a, what are we writing? It's not a plus h, it's going to be, what is a is 0, 0 plus h minus what? F of 0 all over what? H. Okay, let's simplify this a little bit. The limit as h goes to 0 of f of h minus f of 0 over h. But what is the function? The function is c to the x, correct? So we have the limit as h goes to 0 of c to the h minus c to the over. What is c to the 0? So we have f prime at 0. The derivative of this function at 0 is the limit as h goes to 0 of what? C to the h minus 1 all over h. Let's go back and write down what we just said here. We came up with this before, right? Remember this? This was the derivative of the function in general, correct? This was the derivative of the function in general for any a value. Remember how we did these at first and you didn't really see the reason why, but the reason why is if we find this, all we have to do is plug in the a value and we're done, correct? What is this? Do you see it? It's right there. Everybody sees that? This thing right here is equal to what? F prime at 0. So this is the key realization here. Ready? I'm going to write this again one more time. If f of x is equal to c to the x, then f prime of x at a, f prime of a is equal to c to the a times what? F prime at 0. So here's the thing. If I gave you this function right here, you have c, right? And you have the value you're trying to evaluate the derivative at. Can you calculate c to the a pretty easily? Yeah. Yes, absolutely. You can calculate c to the a. So what's the missing thing here? f prime at
0.
f prime at 0. So if we know what the derivative is at 0, we know the derivatives for all of the other ones. All of the other possible values. We need the derivative at 0. So what's the point? What's the point? And I do have a punchline for you. I do have a punchline for you. I promise. To use which base. Now here's the thing. If you can, bases can be anything you want in logland. But what's a really nice base? Log base E. Things tend to get real nice when you use base E, or they don't get as bad as they could get. Can you do things in like base 13 if you wanted to? Yeah, but nothing really cool happens with 13 except bad horror movies. To 2. So f prime of x, we want it to be equal to 2, but we know that f prime of x is equal to e to the x. So the question now becomes, where does e to the x equal 2? What do you need to remember in order to do this basic problem? You must remember how to use logs. This is in exponential form. This is in exponential form. Can someone tell me what the log form of this is? Noah.
Log base E
Of
2
is equal to x. So x is equal to ln 2. That's the way log base E is ln, right? That is the x coordinate, but what else do we need? We need the y coordinate. This thing is asking at what point. You would not get full credit on this if you just said ln 2. That is not a point. That is an x value. So you take this and you plug it in where? In the original function. So what is f of ln 2? That's e to the ln 2. Does anybody remember what that is equal to?
It's 2.
It's 2. The question is, and it is not trivial to remember this, everybody, but the question is this. If you have e to the log base e of 2, what does that equal? You put a question mark up. What form is that in? Is that in exponential logarithmic form? That's in exponential form right there. It's something to a power. The power has a log in it, but it is still, the overall thing is exponential form. If you translate this statement into logarithmic form, it would be log base e of question mark is equal to log base e of 2. And here's the question. If log base e of question mark equals log base e of 2, what does question mark have to equal? 2. What this means, as a side note, everybody, a to the log base a of x is always equal to x. A to the log base a of x, you can write that down. That is a hugely important statement. So you go back to here, we know it's equal to 2. So what's the answer to this question? Sorry. The answer to this question would be, what's the point? ln 2, comma 2. That would be the answer to that question. Now here's the thing. This right here is a conceptual question because are you doing major limits to find a derivative? No. Question? Yeah, go ahead.
Can't you put in ln 2 calculator?
Yes, but this kind of question you would absolutely not have your calculator for something like this.